welcome to this lesson. So in this lesson, we're going to continue our discussion on repetition loops. So where are we right now? We started all of this by discussing the two types of programs that you can write. You can write a function and you can write a subroutine, right? A function, very briefly, is if you're calculating and you're seeking a final output and that's all you're doing, you would write a function. If you're doing two or more actions, you would write a subroutine. For instance, when we were not only calculating, but we're displaying as well, that is an example of what a subroutine is. Then we went into the three structures of programming: sequence, repetition, and decision structure. And with sequence, it's very simple, that things in programming are done in order. And we saw also what pitfall we can fall into, that if you're doing a calculation and the variables are defined after that line of code, you will have an error. So things have to be done in sequence. The second thing that we discussed is the repetition loop, and we said that there are two types of repetition loops: a for next loop and a do while loop. And a repetition loop in general is just you're repeating an action, and in the previous lesson, the action that we were repeating is the action of addition, right? And we said there are there's one difference between a for next loop and a do while loop. That if you know the number of times you want to repeat an action, you would use a for next loop. If you don't know the number of times that you need to repeat an action, but you know a criteria that you need to meet, you would use a do while loop. And an example that we said that in numerical methods, the criteria that you need to meet is that you need an answer that is, say, less than 0.1% error. So that's the criteria. You're not sure whether that will take 10 approximations or 100 approximations or 1,000 approximations to reach that error, but you know that you require that error. Because we're going to go through many techniques in numerical methods. They're going to vary in the number of iterations they're going to get to the final answer. Some would take a long time, that is an inefficient technique, for instance, and some reach the error they want very quickly, so that will be an accurate and an efficient technique. So in this lesson, we're going to write two do-while loops. The first one, we're going to write a do-while loop that will imitate exactly what a for-next loop does. Say, when we know that we have 10 loops to do, right? We want to repeat addition 10 times. So we can write a do-while loop that will do the same thing as a for-next does. So that is one thing I want to show. And the second do-while loop is we're going to see how it works when it's only dealing with a criteria. Okay, so in addition to that, I'm going to introduce something called the isEmpty keyword. Basically, it looks at every cell and it sees whether or not the cell is empty or not, and also how to comment out an entire section. And that is actually very useful when there's only a part of the code that you want to run. So how do you comment out an entire section instead of commenting every single line on its own? So let's begin. So the first thing I want to do is I want to create a new module, and then I'm going to rename the module. Let's call it do while, and I'm going to call my subroutine, so sub do while, and enter. So I created my sub. So much like with the for next, I have a starting statement and an ending statement. For a for next loop, with the starting statement was for I equal to 1 to 10, and the ending statement is next I. So for the do while, it's just do while. And the criteria that I'm going to have, I'm going to use the letter I, and that's going to be for my rows. And I have 10 rows here. I need to sum. So basically, I'm saying to this loop, do while the rows are less than or equal to 10. So if the row is 1, keep adding. If the row is 2, keep adding. If the row is 3, and so on. But if the row is 11, break out of loop, no longer add. Because here, if we go to the 11th row, given that this is the first one, it's empty, right? There's nothing, so stop. If you remember from the last lesson, the sum code is just sum is equal to sum plus cells, and the address of the first element here is at 16 plus I and 2. And the reason it's 16 plus I, because for the first I is going to be 17 and 2, and this is the address of this first one. For the second I, 18, 2, 19, 2, and so on. Now to close the do while, you close it by just saying loop. So basically with the do while loop, you just say do while and the criteria, in this case I is less than or equal to 10, and then I want to loop. We said with anything that we add in the code we have to initialize, so with the sum, much like with the for next, I'm going to initialize at 0. But there's one more thing here that I added that I have to initialize, which is the I. Unlike the for next would up the I every single time, but the do while does not. So here I need to write two lines of code for this I. The first one is to initialize the I at 1, because I want to start at row 1 and up into 2, 3, 4, and so on. But at the same time, if I go in here and say do while is 1 less than or equal to 10, yes, so it's going to go in and is going to do the first sum. So it's going to be 0 plus 1 here. But when it's going to loop, the I is going to be still stuck at 1. So I need a line of code here that ups the I by 1 for every single loop. And it's a very simple sum code as well. So I is equal to I plus 1. So let's see how this code would work. So I initialize I at 1 and the sum at 0. So the first one is I is equal to 1, so that is less than or equal to 10, so it's going to go inside the loop. So it's going to be sum is equal to 0 plus 1. Then I here is going to be 2 now. That is 2 less than or equal to 10 is going to do the second sum, so I is 3 less than or equal to 10, and it's going to keep looping. So the second thing, or the last thing in this code that I want to do is I want to display it here, right? I have the address of this is 27 and 2, and 27 and 2, and I want to add the sum in this cell. And we said whatever is on the right is stored in whatever is on the left. So I'm storing whatever the number inside of sum in this cell, right? So let's actually run our code and see if we're going to get the same answer as we got for the for next. And if you remember, we got 55 for that. So if I run the code, and here we got 55. Now, the second code I'm going to write is one that is dependent on a criteria instead of us doing 10 rows, where I is the number of rows. And before I want to do that, I want to completely cancel this code or let it not visible for VBA to run it. And the way you can actually comment out this entire thing is by those two icons on the top here. So if I press on this, I commented out the entire code. If I highlight it again, and the one that has the blue arrow will undo what you did. So for the sake of this, I'm going to comment this out, and I'm going to write my new code. So I'm going to say do while, and now my criteria, I'm going to use a keyword called is empty, which the criteria I'm going to do is, I'm going to say, okay, start with this cell. Is it empty or is it full? If it's full, add. Is this empty or full? Is it full? Add, and keep going until it's going to come to this cell. Is empty, is going to break out. So I'm going to say do while not, and I'm going to use the word keyword is empty. And I'm going to put the cells, and that's going to be still 16 plus I. But instead of being column 2, now it's column 4. Okay, I forgot a parenthesis here. And we close this by saying loop. So this reads a little bit awkward. Do while not is empty. So basically what this says is do while the cell is not empty. So this is how it would actually properly read. We're still going to have the same code in here. This is what we're repeating. So I'm going to copy this, and I'm going to paste it here. And I'm going to use this over here to uncomment this. So the thing that I need to do, I need to initialize the I is equal to 1, and the sum is equal to 0. And also, I'm going to take this line of code, and I'm now going to put it in 27 and 4. So let's see what's happening here. Do while not empty. What is the first one? Is basically 17 and 4, which is that, and it's going to find that it is not empty. So it's going to go in and it's going to sum 0 plus 1. Then it's going to up the I by 2 and go to this cell. And is this empty? No, it's not. It's going to go in and sum until it goes into this one over here. And it's going to find that it is empty. It's going to break out of the loop, and it's going to display whatever that sum is in this cell. So let's run the code. and it's going to do while, run, and we have 55, right? So let's actually delete this and this, and let's uncomment this and run the codes simultaneously. So if I run this, it's going to go ahead and create this first sum using this 10 numbers, and it's going to display the final output here. And for this one, it's going to take those 10 and create the final output here. So if I run, I get the 55 here and the 55 here. Okay. Now, the one thing I want to address, this might seem too simple, right? That later on when we're dealing with numerical methods, it will get more complex. And I want to assure you that it will maintain its simplicity. Mostly with programming, the complexity comes from having too many parts inside of the code. But if you look at every single part and you find and you understand what this loop is doing, what action is being repeated, or what decision is being made here, they still maintain their simplicity. So if this seems too simple, that is because it is. And I assure you that later in future lessons, it will still maintain its simplicity. Now, to recap what we did in this lesson we introduced the do-while loop. We created a loop that imitates exactly what the for next does by knowing that we have 10 rows that we need to add. And we created another do-while loop that follows a criteria, and we introduced the isEmpty keyword. And the criteria was, if the cell is not empty, keep adding until it's empty, break out and display the sum. And we also learned how to comment out an entire section if need be. I use this because sometimes if I'm debugging, or another word, trying to figure out what my code is doing, or trying to find an error, sometimes I would comment out 3/4 of, say, of my code, and I would only run a certain part to see if it's running properly. And I need to exclude it. And the way I exclude this is by commenting the rest of the code and only running this and seeing what the output is. So commenting out entire sections can be very, very useful. Well, that's it for this lesson, and I'll see you in the next lesson.